Hi there and welcome to another Bug Bites tutorial. In this tutorial we're going to take a look at the BeautifulSoup library in Python. Now this is a library that's used for scraping web data from the internet and getting it into your application or your database. So basically you take raw data from the internet, from websites, and then you can extract pieces of relevant information from those sites using BeautifulSoup. So let's get started with the tutorial. What we've got here is we've got the BeautifulSoup object that we've imported from the library, and we've also got some dummy HTML here, which is a paragraph tag which wraps some text, and there's also a couple of span tags within that paragraph that both have IDs, and one of them also has a class, and we're going to look at all of that in this video. We've also got an EM tag at the end as well. So let's get started with this. This is just going to be something that we're going to use to learn the basics of BeautifulSoup. In a later video, or the next video, we're going to look at a real life example, and we're going to scrape the football scores from the European Championships from the BBC website. So that's coming up, but before that video, you might want to watch this video to get an idea of how BeautifulSoup works. If you're a BeautifulSoup expert, you might want to skip to that next video when it's available. So let's get started. We're going to create the BeautifulSoup object by passing our dummy HTML to the BeautifulSoup constructor. So we'll create a variable called soup, and to the BeautifulSoup constructor we pass the HTML, and we can pass a parser as well. And if we view what is returned from that, we get the text. But there is a distinction here. This is an object of type BeautifulSoup, and that gives it some methods and properties that we can then use to extract data and find particular bits of data in our document. So that's the basics there of how you actually get the HTML into a BeautifulSoup object. What we can then do is we can start looking to find particular elements. So in a new cell here, I'm going to find all the span tags, and we can do that with the FindAll method. To the FindAll method we pass an element, and in this case a span, and what we get is a list. We get a list with our two spans in that list. So that's how you can target a particular element, in this case a span tag. We can also do this with the EM tag, and we would get back a list with that one EM tag. So one of the things you need to know about FindAll, it returns a list. Even when there's only one object, you'll get a list. On the other hand, there is also a find method, and that will return a single BeautifulSoup tag. So that's a tag. Again, if we look at the type of that object, we'll find that it's a tag, BS4 element tag. And that's the second thing you should really know. The distinction between find and FindAll is that the find method returns a single tag object that you can then use. So that's two different functions you're going to very commonly come across in BeautifulSoup: FindAll and Find. And you use these functions to target particular bits of data in your documents. It's very important because that's the whole point of BeautifulSoup. You're trying to get particular bits of information from a web document. Now the FindAll method is actually so common that there's an alternative syntax. You don't need to say FindAll. You can actually just invoke the soup object directly, because it's actually a callable object. So if I look for the spans like that, I get another list back with the two spans. And even though this is a Python object, soup, it's not a function, but it can be called like a function. And the reason for that is that it's a callable. And what that means is that even though it's an object, it defines a dunder call method. And I'm going to show you that now in the BeautifulSoup source code. So this is the actual source code for the BeautifulSoup library. And we see the dunder call method here. Now this is what function is actually called when you use this syntax here and use the callable syntax. And you can see it's just a synonym for FindAll. It just wraps the self.findAll function. So when you invoke the soup object as a callable, you're essentially, under the hood, you're calling the FindAll function. So that's just a bit of advanced knowledge there for you. You might want to read up on callables in Python and how you can make objects callable with the dunder call method. Now let's move on to more BeautifulSoup. Now we're going to look at how to find particular elements and get the text within them. So if I find the EM tag, that gives us back the HTML EM tag. And let's store that in a variable called EM. And if we look at EM, again we get back the tag, but the tags have a text attribute which can give you the text within the tag. And in this case it's web pages. And if you look at the original document, the EM tag wraps this web pages. So you can do that with any object. We can do it with the P object, and we get back the text within the paragraph. And if we look at soup.find and we put the span in there, this will return the first span. Because it's find and not find all, it will only return one object, and that will be the first one that it encounters in the HTML. In that case is this one, and that has the text random. So we get back random when we look at the .text attribute. And we can actually do further nested calls like this. So let's say I found the P tag, we'll call it P here. If I look at p.text, you can see we get the whole thing back, but we can actually look at nested properties. So this will look at the first span, p.span.text, and it will give us back the random. So you can use the dot syntax to look through the document, and that way you can find elements using that nested dot syntax. Quite interesting. Now let's look at some keyword arguments to find all. If I look at if I define a find all function, let's find all the spans. We get back a list with both spans, but there is a limit keyword that can limit the amount of results you get. So for example, if I say limit equals 1, we would only get back a list with that single span, which is the first span. And this operates very similarly to the SQL limit statement. You're basically limiting the amount of results that you get back from the function call, and that can be used useful if you're dealing with a huge document. In addition to that, we can specify a second argument as a dictionary, and that will allow you to search for particular key value pairs, for example IDs. So you see that the first span has an ID of span 1. So if I specify an ID in that dictionary equal to span 1, the find all function will return a list with that single span with the ID of span 1. So I can change that to span 2, and that will give me the second span. And obviously in an HTML document, an ID is unique, so you should probably use find in this case, and that will give you the actual tag back rather than a list with the tags. But you can always index into the list with 0 to get that first element as well using find all. So you can search for IDs. You can actually search for any attributes in an HTML element. For example, you might want to look for the class of random span. So if I look for class random span, I would get back that first span there with that class. And HTML elements can have multiple, a class can apply to multiple HTML elements. So if I give the second span that same class and execute this again, we would get back both because they now both have that class. Let me just change that back here. And so you can specify any key value pairs in this dictionary, which is the second parameter to find and find all, and that will help you identify the particular elements that you're interested in order to get the data that you need. So let's go on to another example. So if I find, let's again store this in a variable, and we'll call it tag. If we look at the span with that class, we get back a BeautifulSoup tag object, and that has a function called hasAttrib, which stands for has attribute, and we can look to see if does that span that we're looking at have an ID attribute. Now let's look at the span up here. We've got a span with that class, and it does have an ID attribute. Now if I was to look for the ID of span 2 here, and that would give us back the tag with span 2. It does not have a class, so the has attribute class, if I pass in the class attribute, it's going to return false here. So this has attribute function, rather, it returns true or false based on whether the given parameter is an attribute on the tag that you're looking at. This is a function available on BeautifulSoup tag objects, and it can be quite useful if you're checking for a class or any other HTML attribute. Similarly, tags have, if you wanted to list all the attributes on a tag, you can use the attrs. This is a property, not a function. You just need to call it. You just need to define it rather. You don't need to call it, and it will give you back all the properties. So in this case, we've got an ID of span2. That's the only property on this span. If I look at span1, it would give us back ID of span1, but you would also have a class property, which is a list with a single class, and you can actually extend that in any way you want. I could give it a name equals XYZ, and then if I look at the tags attributes, we would find that there's a name tag in there as well. So this will give you back all the attributes on an HTML element. Quite useful to know that. Let's revert back to the original HTML. Now let's look at something a little bit more advanced. I'm going to clear this cell, and we're going to see that the parameter, the first parameter to find in FindAll, doesn't need to be a string with the element. It can actually be a callable, it can be a function. So let's define a function called HasClass, which will take in a tag, and we're simply going to return whether or not that tag has a class attribute. So hasAttr class. So this will return true if the tag has a class attribute and false otherwise. So now we can use that to find all the elements in the HTML document that have a class by just passing the function as an argument. And we get back two elements. We get back the span, which has a class of random span. We also get back the EM tag with a class of XYZ. These two elements both have a class, therefore this function returns true when BeautifulSoup is evaluating them, and therefore we get them both back. If we added a class to the P tag, say AA, and we execute this again, we would now get three elements. One is the P tag, and we get the other two that we had before. So this callable, you can have a very complex callable if you want, where you perform any logic needed, and you can then find all the elements with whatever the callable evaluates to true. So let's move on now, and we'll define a new cell here. We're going to look at how to look for multiple HTML tags with the FindAll function, and this applies to find as well. Now we've seen how to find a span element, for example, and we've seen how to find an EM tag, but what if you wanted to find all spans and EM tags? Well, you define a list, and in that list you can pass as many different attributes as you want, as many different HTML elements as you want, and call FindAll, and you'll get back a list with all of those HTML elements. In this case, we wanted to find span and EM, so we get the two span tags, and we also get an EM tag in that list. And again, this can have as many HTML elements as you want. We could add the P tag here, and we would get back the P tag as well as the other three. So quite useful to know that this doesn't need to be just a string with one element. You can define multiple elements of interest and call the find and FindAll functions to try and find those elements. Quite useful to know that. So in the next section of this video, we're going to look at how to find a tag's children with two properties. I'm going to, let me just paste some text in here that will explain this a bit better, and we'll do a code block under that. So a tag's children can be accessed with two properties. There's the .contents property and the .children property. And there's a subtle distinction here between these two. The .contents, it returns a list with all of the tag's children. The .children property returns a Python generator that yields the children when it is asked one at a time, and that could be more memory efficient in Python. Generators are good for dealing with a lot of data, and if you don't need the elements to be accessible by an index, a generator can be a more memory efficient way to look at things. So let's cover both of these methods now. We'll first of all look at soup.contents. So if I look at the BeautifulSoup object itself that represents the whole document, and we look at .contents, we find we get a list with one element essentially. But what I can do is I can find, for example, the paragraph tag, and we can get from the paragraph tag that has multiple children. It has a child here for the first bit of text, then a child for the span tag, then the next bit of text, the next span tag, and so on. So this is a list, as it says up here. .contents yields it returns a list with all of the children, and we can find, for example, the span tag. That'll give us the first span tag's children. In this case, it's just a single text element, and that can be used to find the children of a given tag. Now that's one method. We can also look at the children method. Now soup.find, let's say we find the p tag. If we wanted to find the children of the p tag, we could access the .children attribute. Now in this case it returns a list iterator, so that, as it implies, means we can iterate over it. So for child in soup.find p.children, we could then, let's say, just print the child out to the terminal, and we can get on each line each child of the p tag. Now these give essentially the same results, but one returns a list, the other is yielding the children one at a time as it's asked for them in the for loop. A subtle distinction. Usually I don't think it would matter which one of these you use, so you can use either one of them. I like to use .contents, to be honest, because working with a list seems quite natural. You can then iterate over it if you want, and unless you're dealing with huge amounts of data, it's probably going to be faster and easier than using .children, but it's your preference. Now these two attributes, they only apply to direct children of a Beautiful Soup tag. Let's introduce a new attribute called .descendants. I'm going to paste some text in here. And the .descendants attribute lets you iterate over all of a tag's children recursively. So it's not just the direct children, but it's actually the children of the children. Remembering that the HTML document is a graph-like structure, it has, or a tree-like structure. It has a root node which has children, and then those children also have children, and so on. So if you're at a given node in the tree, you might want to look all the way down to find all of the descendants, and that's what the .descendants attribute allows you to do. So if we then look at soup.find the p tag, and we want to see all the descendants of the p tag, this will return a generator, and we can then loop over that generator, or we could just convert it to a list actually to look at all of the children, or all of the descendants. And in this case it's a recursive output we get. It's similar to what we had before. We get the text, we get the span tag with random in it, but because it's recursive, it goes into that span tag as well, and it prints out all of that tag's children, in this case just the text random, and so on. So it's recursive. We get more child elements here using .descendants than we did with contents and children. So that's another way to look from a given node down into the children. We can use the .descendants property, and there's a similar property called .parent as well, which allows you to look at the parent tag of an element. Let's say we want to find the p tag, or rather the span tag. We know that the parent of the span tag is the p tag, so if we call .parent on that span tag, we get the p tag that contains it because it's the parent element. So descendants, parent, we've also got contents and children. These are ways to look at a given HTML tag in your document, and then you can find other tags that are next to it in the document tree. And you can also look at an element's siblings in the document as well. So for example, for the p tag here, we could look at the first span tag and say, well, what's the siblings of that span tag? So you can do all sorts of things with Beautiful Soup to navigate the tree. You can also modify the document. We're going to come to that later, because I want to now look at another alternative way to search for elements. We've seen the find function and we've seen the FindAll function, but let me paste a bit of text in here. We've also got these CSS selectors that you can use as well. Now Beautiful Soup tags, they have a .select function that allows you to find elements in the document using the CSS selector like syntax. Now you might be familiar with that from CSS style sheets, or even from things like jQuery if you do any web development. These are selector expressions that you can use to target specific elements in the document, and Beautiful Soup has this select function and also a select one function which returns a single element. So these are similar to FindAll. Select is similar to FindAll, select one is similar to find. Let's see how they're used now. So we can use it in a simple manner like soup.select to find all the span tags. This is just equivalent to FindAll. Where this really shines is the use of CSS syntax such as that. So what we're saying here is find the span that has the ID of span2. The hash is CSS syntax for an HTML ID, and that gives us back that single span with the ID of span2. And we can also use select one here to get back a single element rather than a list. so that's just like find. But you can actually build up very complicated CSS expressions. So let's say we wanted to find p tags and we wanted to find the first span, so we could use the nth of type pseudo class, I think it's called in CSS. What that's saying is look at the p tag and find its direct children that are span objects, and only find the first. We can then put in, we could also find the second child, second direct child, like that. So you can build up these complicated CSS expressions. And we can also find multiple elements by comma delimiting the values. So let's say we wanted to find all spans and all EM tags. We just comma separate them and we get them back. Now that's basically equivalent to FindAll, where you pass in a list of span and EM. They give the same result, a list with the elements. So you can see the power of this. It allows you to build up expressions using CSS syntax, and that can be quite elegant for finding particular elements in the document. And if you're a web developer, this syntax is natural and can be very useful if you're using BeautifulSoup. Finally, in this video, I would like to cover modifying the document a bit. Let's paste a bit of text in here. So BeautifulSoup allows you to modify the HTML document. So let's try and modify the document now. Let's find the first span tag and we'll print that out. And what we're going to do is we're going to change the tag to a paragraph tag. So it's a span tag, we want to change that to a paragraph tag. So what we need to do is access the .name attribute, and then we can reset that to a p tag. And then if we look at the tag, you can see that the span has been changed to a p tag. And if I look at the original, this actually modifies the original BeautifulSoup object. So what we have is a p tag, but you can see that the span within there is now also a p tag. So that has changed the soup object in place when we changed the .name attribute. And we can also change HTML attributes. So for example, the p tag has a class of random span and it has an ID of span1. I could reset the ID to, let's say, new ID using this dictionary-like syntax. All the attributes are available on the tag using this dictionary-like syntax, and we're reassigning the ID, which is currently span1, to a new ID of new ID. So if we look at the soup document after that, you find that the paragraph tag has a new ID now. So that's how you modify the actual elements within the document. You can do that using BeautifulSoup. And finally, if you wanted to clear out a tag, let's clear out a tag using the .clear function. And if we use that and look at the BeautifulSoup object, you see that the p tag's children, and that's what this .clear function does, it removes all the children. You can see that it's now an empty tag, there is no text in there. Before we had random, now there's nothing because we've called .clear. And if I call .clear on, let's say, on the p tag, which is, remember, the root tag, the first tag, that will actually remove everything underneath the p tag. So if we look at the soup object, we'll just get an empty p tag now. So that's about it for this video. The code in much more detail will be on GitHub. I'll link to that in the description, and there will also be an associated blog post as well. In the next video, we're going to look at a more interesting real-life example. We're going to look at football data, the European Championships, and how to scrape the results from that championship and get it into a format that we want it in. That's a more realistic way that you would use BeautifulSoup, by going to a website and getting the data and then using it in some way that's useful to your application. We're going to look at that in the next video, but for now, if you've enjoyed this video, if you've learned anything useful, please like and subscribe. We'd really appreciate that. And until next time, thank you for watching and goodbye.